Good morning, student. Welcome to the lecture number 23 in petrochemical technology. So here we will study about the conversion process. This is the next topic. So basically the conversion process in the refinery, the more detailed information about this and what happens into these processes. So we will discuss into this lecture. So if you talk about an oil refinery, uh, basically the conversion process involves the various techniques aimed at altering the molecular structure of the crude oil fractions to enhance their value. So we improve the molecular structures, we crack the different distillates to get the valuable product and to improve its property and to improve its yield and higher value product. So conversion process are crucial in refining because they are enable the transformation of heavier, less valuable fractions into the higher or more valuable products. So here are some key conversion process commonly used in the refinery. The first one is cracking. The cracking process breaks down the heavy hydrocarbon into lighter ones, and this will include the fluid catalytic cracking, that is FCC. So into the fluid cracking, catalytic cracking, using a catalyst to convert heavy gas oil and vacuum gas oil into the lighter product like gasoline and diesel. So these are the valuable product into the refinery. Gasoline is basically your petrol that you use in your bikes or cars, and diesel is for the fuel for heavy vehicles like trucks and buses, etc. So next we will come to know about the hydrocracking. This is the another conversion process into the refinery. In hydrocracking, this is the process that combines the catalytic cracking with hydrogen to break heavier molecule into lighter product, and hydrogen molecules are added to improve the properties and convert into the lighter product like gases and the marketable product primarily used to produce high quality diesel fuel. So this is basically used to produce the high quality diesel. The another process is coking. So coking process thermally cracks heavy residual oil which are highly viscous and they contains big chain of the carbons. So coking process thermally crack heavy residual oils into lighter product, and this includes the delayed coking and fluid coking. So first we will talk about the delayed coking. It involves the heating heavy residual oil to high temperature to break it down into the lighter fraction. So at this happens at very high temperature, and heating the uh, we are heating the heavier hydrocarbons, that is basically the high viscous and that contains the long chain of carbon that distillate obtained from the refinery. So it at high temperature this hydrocarbon break it down into the lighter fraction and producing the coke as a byproduct. So coke is a basically your carbon, so that is a byproduct, and this complete hydrocarbon is converted into lighter product which are more valuable into the market. And next is fluid coking. So a continuous coking process that converts heavy oil into the lighter product, similar to delayed coking but in a fluidized bed reactor. So this reaction is similar to the delayed coking, but it happens into the fluidized bed reactor, and delayed coking does not happen into the fluidized bed reactor. So coming to the next slide, we have the hydrotreating. Hydrotreating is another process, conversion process into the refinery. So hydrotreating uses hydrogen and a catalyst to remove the sulfur, nitrogen and other impurities from petroleum fractions like diesel, kerosene and naphtha. So these heavier fractions like diesel, kerosene and naphtha that contains the impurities like sulfur, nitrogen and other impurities. So into the hydrotreating method we use some catalyst and hydrogen to remove these impurities. It also helps in saturating unsaturating hydrocarbon to improve the product quality. And next conversion process we have is, that is isomerization. So this process rearrange the molecular structure of the hydrocarbon to produce isomers with same chemical formula but different structures. So because if we have three number of carbon or five number of carbon, it has the single molecule along with other isomers. So isomers have different value, different properties compared to the another isomer. So we convert the hydrocarbon into the valuable product using the isomerization technique. So in this process we rearrange the molecular structure of the hydrocarbon to produce isomers with the same chemical formula but different structures. So isomerization is used to increase the octane rating of gasoline by converting straight chain molecule to branch chain isomers. And if you talk about the another process, that is alkylation. Alkylation combines the smaller low value hydrocarbon, usually olefins such as propylene and butylene. So small alkanes are combined to convert into the valuable product. Like it combines the smaller low value hydrocarbon, usually olefins such as propylene and butylene, with isobutane to form high octane gasoline component. So it is basically uh, this process is used to combine the smaller olefin molecule into the uh, long chain hydrocarbon that are valuable with uh, high octane numbers. So into this process we basically get the product that is high octane gasoline component. So next, coming to the another slide, we have reforming, that is another process of conversion into the refinery. So in reforming we have the catalytic reforming that converts the low octane naphtha into high octane gasoline blending component and produces the hydrogen. So this process involves rearranging of the hydrocarbon molecule and removing the impurities. So these conversion processes are designed to minimize or maximize the production of higher value products like gasoline, diesel, jet fuel, petrochemical feedstock from the various fractions of obtained during the crude oil refining. So during the crude oil refining, sometimes the demand of some particular product increases. Say for example the diesel demand is high, so from the crude oil we get the limited amount of diesel, and the other product which are not very much valuable and are in less into the demand into the market. So these products are getting converted into the valuable product which are there into the demand of the market. So this process helps in increasing the production of the demanding product. Like gasoline has high demand, so we need to produce the high amount of gasoline by improving the quality of other product. So the choice and optimization of conversion process depends upon the composition of the crude oil, market demand, and product specifications. Say for example, the properties of the different product must meet into certain specification which our client is demanding. And economic factor, we have to see the economic factor also, like the supply, demand, and market value, etc. So coming to the next slide, this is a small process diagram of the reforming into the refinery unit. So you can see from the desalting of the crude oil, the different products are coming, like light gases, naphtha, we have kerosene, gas oil, and this is a saturated gas recovery, this is unsaturated gas recovery. Then naphtha hydrotreater, we have distillate hydrotreater, fluid catalytic cracking, hydrocracker, reformer, isomerization, and coking with breaking, fluid catalytic cracking, VDU. So these are the different reforming process into the refinery, and out of this reforming processes we are getting the valuable product with improved specifications and economical conditions. So LPG, gasoline, kerosene, diesel, fuel oil. These products are based on the demand of the market. So this is the auxiliary system into the refinery, like SRU, AGRU, and gas generation, sour, water stripper, etc. And at the bottom we have given you the utility system that is into the refinery, like for example intake, air, nitrogen, fuel system, power, effluent treatment, drain, storage, logistics, steam generation, and DM water cooking. So these are the other utility system into the refinery. This is another picture of the uh, different reforming process into the refinery. So you see we have atmospheric distillation tower. From here we have received the LPG, and then it is going further to the distillate hydrotreater, from where we are improving the quality of the kerosene, and we are getting the jet fuel and diesel. And here into the vacuum distillation tower, this product is further going for the hydrocracking process. This is another reforming process. So out of this hydrocracking process we are improving the quality of jet diesel and bottoms to FCC lube plant or recycle. This is a FCC, that is fluid catalytic cracking unit. From vacuum gas oil, this is further improving the property of the petroleum product. We are getting the olefins to alkylation or olefin plant, then gasoline, then cycle oil blending, hydrotreating, and hydrocracking. And this is the coking unit, where we are final product, the bottom product that we are receiving, that is petroleum coke. At the top you see the naphtha hydrotreating. Into the naphtha hydrotreating we have the reforming process, that is isomerization, and we are getting the gasoline. And here again we have catalytic reforming. The catalytic reforming, out of that we are getting the gasoline and aromatics. So this is the detailed diagram of the reforming process into the refinery. So further to the next topic, we will continue into the next lecture. For any question you can write me, or you can send me a WhatsApp message. Thank you.